So for this lesson, we're going to cover the concept of area and then use this concept to understand the area of a rectangle in a parallelogram. So if you look at the word area in a dictionary, it will tell you that it means a certain space or region. So in mathematics, what we do is we try to quantify this space or region. And how can we go about doing that? Well, the first step of quantifying anything would be to define a unit to quantify it by. And a unit is something that represents a single entity. So for example, in the USA, money, the unit of money is dollars. And if you go, let's say, to London, the unit of money would be pounds. And if you think of units of measurement, we have centimeters, inches, then there's meters, kilometers, and so on. Time is measured in units of either seconds, minutes, or hours. And temperature is measured in Celsius or Fahrenheit, depending on where you are. So these are examples of units. So putting all that into consideration, what can we use as a unit to measure area? Well, first let's think of the units of length. And common units of length is the centimeter and the inch. Now, if we make a box that is 1 centimeter thick and 1 centimeter long, and another box that's 1 inch thick and 1 inch long, like these two boxes, we form a square. And the purple square will have a unit of 1 centimeter squared, and the orange square is going to have a unit of 1 inch squared. These are common units of measuring area. Now for the rest of this video, we're going to define our own unit, which is going to be this blue box, and we're going to call it a unit square, because your answers for finding area will differ depending on which unit you use, but the concept of finding area will remain the same. So let's say we have these two rectangles and we want to find their area. Well, first step would be to place our unit squares along each of the rectangles. So if we keep placing them, and you have to place them so they all fit as perfectly as possible next to one another. Now to find the area, all we would do is count how many unit boxes we ended up with, and that'll tell us the area of that rectangle. And for this rectangle, if you count all the boxes, you end up with 24 boxes. So this rectangle has an area of 24 unit squares. But also notice that along this side we have 6 unit boxes, and along this side we have 4 unit boxes. So if we multiply these, we also get 24, which is, as we said earlier, the area of this rectangle. Same way, if we cover the second rectangle with the unit squares, we end up with 6 along this side and 3 along this side, and instead of counting each box individually, we could just multiply them and we end up with 18 unit boxes. So the area of the second rectangle is 18 units square. Now if you notice, a faster way of finding the area of both these rectangles were to just count how many boxes go along each side and then multiplying them. So if we want to generalize the area, then we can call, for example, this side the base length and this side the height. And to find the area, all we did was multiply the height and the base. So that gives you the area of rectangle is base times height. Now that we understand how we get the area of rectangle to be base times height, let's see how we can apply this concept to parallelograms. Now if you place the unit squares along the parallelogram, you notice that they don't fit as perfectly as they did on the rectangle. There's a lot of empty spaces. So there's no surety whether multiplying the base and the height of this parallelogram would give the area. So now let's see if we can use this concept of area of a rectangle to help us find what the area of a parallelogram should be. So let's first start with our parallelogram. and then cut it up like this. That way we have two triangles and a rectangle in the center. And then let's say the base of this triangle is length x, which is going to be equal to the base of the other triangle because they're both congruent triangles. And then let's say that the length of this side of the rectangle is y, and which means that the other side is also going to be y because it's a rectangle and opposing sides are equal in length. And lastly, let's say that the height of both the triangles and the rectangle is h. So now that we denoted each of the sides' lengths, let's move the triangles away from each other, and let's bring this triangle right here closer to this triangle. And by doing that, we end up with two rectangles. So this rectangle has a height of h and a base of x, and this rectangle has a height of h and a base of y. So that means that according to our formula, area of the rectangle equals base times height, we have the area of the first rectangle being the base, which is y, times the height, which is h. And the area of the second rectangle being x, which is the base, times, again, h, which is the height. So that means the total area of our parallelogram was going to be the area of this rectangle plus the area of this rectangle. So if we put in the terms, we have y times h plus x times h. And if you can see, this h can be factored out, so we end up with h times y plus x, which we can rearrange to write it as x plus y times h. Now let's bring back our previous parallelogram. If you remember, this is what our parallelogram looked like when at height h, and we said that this length was x and this length was y, which means that the total length of the base of the parallelogram is going to be x plus y. So let's see what happens if we multiply the base times the height of the parallelogram. We'll end up with x plus y times h, which is also equal to what we found over here. So that means in a parallelogram, the area is also equal to base times height, even though when you place the unit squares, they don't fit as perfectly on a parallelogram. The area can be found in the same way as a rectangle, which is base times height. So now we know that the area of a rectangle and a parallelogram is just base times height.